particle is initially at rest at a point with position vector 2j, and t seconds later its acceleration is a meters per second squared, where a is 8 cos 2t I plus 2j. We want an expression for the velocity. So to get the velocity, we know that we have to integrate the acceleration. Cos would integrate to sine. We need to use the chain rule. Remember, we're integrating here, so we'll divide by the 2. So that would give us 4 sine 2t plus a constant. And then here we'll get 2t plus another constant. Now we know it's initially at rest. So when t is 0, it would be at 0, 0. Now sine of 0 is 0, 2 times 0 is 0. So c1 and c2 are equal to 0. So v of 0 is 0, 0. In this case means that c1 is 0 and c2 is 0. And therefore our velocity is 4 sine 2t and 2t. We want to find the value of t when the particle is first travelling parallel to the y-axis. So parallel to y-axis means that the horizontal component of velocity would be 0. So we'll have 4 sine 2t is equal to 0. So we want t greater than 0. The next time the sine is 0 is at pi, and for 2t to be equal to pi, that means that t would be equal to pi by 2. So now we want the position vector, so we need to integrate the velocity. Sine integrates to negative cos, and don't forget the chain rule again, being used in reverse because we're integrating, so that will be negative 2 cos 2t plus a constant, and then we have t squared plus a constant. So we know that r of 0, according to this, is 0, 2. So think about cos of 0. Cos of 0 is 1, so this is negative 2 plus c3. So c3 is going to need to be 2 in order to give us a 0. And then when t is 0, this is 0, and that means that c4 needs to be 2 as well, so that the j component will be equal to 2. Let's just go through the I component again. We know that t is 0, cos of 0 is 1, so this is negative 2. So c3 needs to be equal to 2, so that this component is 0 here. So that gives us that r is equal to negative 2 cos 2t plus 2 and t squared plus 2.